In this lesson, we're going to talk about identifying functions. By the end of this lesson, you should be able to determine whether a relation is a function. The idea of functions we touched upon in the last video, but a function is when a input gets you a specific output each time. So when we talk about functions in the real world, we can see them in soda machines where a certain button is tied to a certain soda, so you press the button, you get the same soda out each time. We see this idea when we talk about conversion, so whether it be converting between inches and or metric and customary, or Celsius and Fahrenheit, what we see is that a specific value, such as 0 degrees Celsius, is attached to a specific value in a different unit of measurement, such as Fahrenheit. So we know that 0 degrees Celsius will always go with 32 degrees Fahrenheit. We also see functions appear when we talk about being paid. So if you work an hourly, if you make an hourly rate, if you work the same amount of hours on 2 different days, the idea is that your pay stays the same, that you get the same amount of money each day. An algebra function is simply a relationship in which the input is tied to a specific output. So each domain x is paired with exactly one range y. And the biggest thing here is that the x values can't be used more than once. So you can't have an x value going to 2 different y values. To identify a function, we check the different methods of representing a relation. And so we can check a mapping diagram, we can look at a table, read the order pairs, and do what's called a vertical line test. And again, what we're looking for here is to make sure that none of the x values are appearing more than once. When we talk about a vertical line test, with the vertical line test, what you do is that you're going to draw a vertical line somewhere on your graph. And you want to check multiple points. The goal in doing this vertical line test is to see if the vertical line that you draw intersects in more than one spot on your graph. If it intersects in only one place, then your graph would be considered a function. But if it intersects in multiple places, so 2 or more places, then it would no longer be considered a function. Okay, there are 3 basic algebraic functions that we're going to be focusing on, and those 3 basic ones are linear, quadratic, and exponential. Each of these is a special type of function, but nevertheless they are all functions. Our main focus for this first part of this particular unit is going to be specifically on linear, and this is when the points form a straight line. But we can't forget about quadratic, which gives us this parabola, this U shape, and we also can't forget about exponential. And there are many more functions that are in the math world, but we're focusing on these 3. Okay, determining if a relation is a function from a mapping diagram. What you need to do is look at the column that has the x's in them, and you're looking at the arrows. You're looking to see, are they mapped to more than one. So here we have 4, -1, 1, and 3. Each one is mapped, is mapped to one y value. So even though we have -1 and 1 both going to -6, that's okay because each one is only going to that one number. I don't have one going to -6 and 11. So this one would be considered a function. But as you can see, the second one would not be considered a function because if you look at 4, this 4 is going to 2 different numbers. So it's going to 2 and it's going to 3. It's okay for the y values to be repeated, but it is not okay for the x's to repeat. The same idea is true in a table. So we're looking at the x column. We're looking to see if any of the x's repeat. So here we have 2 and 2. 1 is going to 6, 1 is going to 4. So this would not be a function because the x value is repeated. We have the same x value twice. But in the second column, we do not have the same x value happening twice. It does not matter that we have 5s repeating in the y values because our focus, again, when we're identifying a function, is to determine if the x values are repeating. Determining whether a function is whether there's a function from ordered pairs, you're doing the same thing. You're going to be looking at the x's. So here we have -2, 2, 8, 3, and 7, all of those are different. So you're safe, and it's a function. When we look at b, we can safely say that b is not a function because we have the 4s repeating more than once. So here we're looking at a graph, and when we look at a graph, we want to determine if it's a function from what we call a vertical line test. So here in our vertical line test, what we're looking at is to see, does the graph intersect at more than one spot? So here it's only intersecting at 1. Here it's intersecting only at one spot. And if we were to drag it all the way across the graph, our graph being this shape right here, we would see that our vertical line only intersects at one point. So this would be considered a function. When we look at the second one, though, we look at b. b would not be considered a function because if I take my vertical line, we can see that it's intersecting at 2 spots. And so that would not be considered a function because we now have x values that are appearing more than once. Determining whether a relation is a function from an equation, I can tell you that these first 3 equations are going to be functions because this first one is linear. Anytime where the x is just an x, there's no exponent on it, it's going to be a linear equation. Anytime that we have x as the exponent, it's going to be considered exponential. And anytime it's x squared and x squared is the highest power that we have, then it's going to be considered quadratic. And all linear, exponential, and quadratic relationships are considered to be functions. This last one, though, is not going to be a function. It's this x equals y squared. If the y is squared, it's never going to be a function because what you're going to get is this shape down here. And what you'll see is that at this particular x, you have 2 different y values that go to it. You may be asking, why is this the case? If we look specifically at this bottom one right here, and I'm taking an x and I put in 2 different numbers, so I have 3 and I have -3. These are 2 different distinct y values. What we notice is that we get out the same x value each time. And remember, we've talked about with a function, we cannot have the x's appearing more than once. It's okay for the y's to appear more than once, but it is not okay for the x's to appear more than one time. If we want to write a rule for a function, what needs to happen in this particular case is what we're looking for is our change in y and our changes in our x. And really what we're looking for is just a pattern. So what's happening from the x to get it to the y? So I usually skip this first point if it has 0 in it because it's a little bit harder to kind of gauge, and I jump over here. So I know to get from 1 to 5, I could add 4, but we know that if we come over here, adding 4 is not going to work. So then I start to think, okay, well, multiplication might be involved. What if instead of adding by 4, I multiplied by 4 and added 1? So if I did 1 times 4, that would be 4, plus 1 would give me 5. If I did 2 times 4, that would be 8, plus 1 would give me 9. If I did 3 times 4, that would be 12, plus 1 would give me 13. And so we see that our pattern for this first one is multiplying the x by 4, so that would be 4 times x, and then adding 1 to it. If we're looking here, we see that 0, 0 is the same, 1, 1 is the same, but then we look at 2, 4. So it's a little bit different. So then we look, okay, 2, 4, 3, 9, 4, 16. What we see is that the y values are all squared of the x's. So the second one would be x squared. And then when we look at the third one, again, we're looking to see, again, we're simply looking for a pattern. So when we're looking for this pattern, again, I'm going to skip this one maybe. I might skip this one. So from 0 to 2, we could add 2, but if I come over here, 1 plus 1, or 1 plus 2 is not 1. So I could add 3 and subtract 1, or add 1 and subtract 2. But let's keep looking. So in this particular pattern, what we would see, or what we're gonna end up seeing in this pattern, is that we multiply by -1. So again, checking for that multiplication and then adding by 2. So if I did 1 times -1, that would be -1 plus 2 is 1. And so that's really what we're looking for here. Alright, before watching the next video, what I would like for you to consider is how a function differs from a relation. Alright, I hope that you found this video helpful. Please subscribe to my channel, and I look forward to seeing you in the next video.